Okay, I am continuing on our limits from tables of values. I just had to restart this little document camera. So anyway, okay, we're going to continue. We have these tables for F, G, and H. In this first question, they're asking which of the following conclusions is supported by the data in the table. I'm looking at everything is on F, and each of them is x is approaching -5. So where would -5 be? -5 would be right here. And I have no idea what the value of the function is there, and I don't care because these are limits, not function values. Well, not the function value at -5 anyway. So as we're approaching -5 from the left, it looks like it's getting closer and closer and closer to 6. As we approach -5 on the right, it looks like we're getting closer and closer and closer to 6. So the limit from the left is equal to the limit from the right, and they're both equal to 6. Therefore, I can say that the overall limit is 6. B. Okay, what about number 3? Now we're moving on to function G. We're still approaching -5. Okay, so here is where, okay, clearly I did not change that, you guys. I'm going to change this now on this paper. I'm sure on yours, by the time you get it, this will be fixed. But we are not approaching -5, we are approaching 7. So let's change, I'm going to change all those to a 7. So here's where 7 would be, right? And again, I don't know or care what the value of the function is right there. I just want to know what it is approaching. Okay, on the left, it looks like it's getting closer and closer and closer to -5. On the right, it looks like it's getting closer and closer and closer to -5. So the overall limit is -5. C. Okay, did I do the same thing here? Yeah, okay. I think we're okay for number 4 here. All right, for h of x, again, we're approaching -5. So -5 would be right here. I don't care what the value of the function is right at -5. I only want the limit. As we approach -5 on the left of -5, it looks like it's getting closer and closer and closer to 3. On the right of -5, the values of the function are getting closer and closer and closer to 4. Therefore, the overall limit does not exist. The limit from the left is not equal to the limit from the right. Okay? A little note here. It is important to note that we are only using the table to draw some probable conclusions. We don't know for sure what's happening as x approaches these values in these problems. All right. Now we're going to talk about limits of compositions of functions. And I would like to begin by discussing some properties of limits. If you have the limit of a sum, that is equal to the sum of the two limits. It's kind of like you can distribute this limit to both pieces. Okay? The limit of a sum is the sum of the limits. Same thing with a difference. Limit of f minus limit of g. The limit of a difference is the difference of the limits. Same thing with a product. A limit of a product is the product of the limits. And same thing with a difference. The limit of a quotient. The limit of a quotient is the quotient of the limits as long as that limit is not 0. Okay? One last property. If you have a constant that is being multiplied by a function, you can take that constant outside of the limit and multiply it by the entire limit. Okay? We do that sometimes. All right. Look at some examples. So now I have two graphs at h and g. First, I want to find the limit as x approaches 2 from the positive side of h plus 2g of x. So that will be the limit as x approaches 2 from the positive side of h plus 2 times the limit as x approaches 2 from the positive side of g. Okay? So let's go get the limit as x approaches 2 from the positive side of h. 2 from the positive side of h, that limit is 3. 2 from the positive side of g. 2 from the positive side, did I do that, you guys? Did I do the positive side? 2 from the, negative 2, negative 2. Negative 2 from the, oh my gosh, yes. Okay, I don't know if I did that right or not. I was looking at positive 2 instead of negative 2, and this is a negative 2. I'm glad I caught that. Okay, negative 2. Negative 2 from the positive side. Negative 2 from the positive side is 3 on h. I got lucky with that one, but I did it the wrong way. Gosh. Negative 2 from the positive side. Negative 2 from the positive side would be here. So that would be 3. For h, negative 2 from the positive side would be 5. So this is 3 plus 10, or 13. Kind of messed that one up. Hopefully I'll do better with this next one. Okay. For number 6, now it's positive 2 from the positive side. Okay. Positive 2 from the positive side. So let's go through this. G of x. Positive 2 from the positive side. That would be 0, right? H of x. Positive 2 from the positive side would be 4. Plus 3 times h, here's h, positive 2 from the positive side is 4, over g. Positive 2 from the positive side is 0. Right there, that gave me a division by 0. This thing is non-existent. Non-existent. So E. Okay. All right, let's talk about this one. The table of value. The table gives values of f. What's the best conclusion of this? All right, x is approaching 5, but when I look in there, I see a negative x. If x is approaching 5, then what are we approaching on f? Negative 5, right? Negative 5 would be right here. So what value is being approached? What is the f value right there? What are we getting closer and closer and closer to? 6 on the left, 6 on the right. So this would be 4 times 6, 24. Alrighty. Okay. Now for probably, you guys, probably the toughest concept in this whole unit. Okay? I think it is. When we have a function composed with another function, not being multiplied, not being subtracted, added, divided, but composed with another function, we have to write an intermediate step with a limit before we get to our final answer, okay? So the best way I can think of to do this is to do several examples, so that's what I'm going to do here. I want the limit as x approaches 1 of g of f of x. G of f of x. Okay? We want the limit as x approaches 1 of g of f of x. All right. I need to write this as another limit. And x will be approaching something that I have to go find out. Okay? So, I would put this 1 in for x, true? In for the f function. So I'm looking on the graph of f. I'm looking on the graph of f as x approaches 1. As x approaches 1 on the graph of f, the y value is approaching 3. It is approaching 3. However, this is the tricky part. That's the easy part. The tricky part is right here. However, this graph, yes, it's approaching 3, but it is always below 3, isn't it? 2.999. 2.999. It's always less than 3. It's approaching 3, but on the left. This becomes a one-sided limit. 2.999 is less than 3. Less than 3. Okay? Now we put that in for g of x. Now we want to go to the graph of g and approach 3, but only on the left. And as we approach 3 on the left, 3 on the left, what is y approaching? Y is approaching 3. Okay? What about this next one? Here is g of f of x as x approaches 3. Okay? So we want the limit as x approaches 3 of g of f of x. I know it's going to be another limit as x approaches something that I'm about to go find out. So I'm going to go to the graph of f and see what happens as x approaches 3. As x approaches 3, the f value is approaching 1. It is approaching 1. However, it's always higher than 1. It's always above 1. 1.001, 1.00001, right? It's always higher than 1. So this is 1 from the right, higher, from the higher side. So now I go to g of x, find out what is g approaching as x approaches 1 from the right. 1 from the right, 1 from the right, g is also approaching 1. Okay, let's do one more with the table. X is approaching 7. G of f of x. Okay, I'm going to start inside. Let x go to 7 on f. X goes to 7 on f. Well, here we are on f. X is going to 7. Y is approaching, f is approaching 4. However, we are below 4, 3.999. Yes, it's approaching 4, but from below. From below. So this is going to equal x is approaching 4 from below of g of x. So I go to g, we're approaching 4 from below, 4 from the left, and 4 from the left is, it happens to be 4. Okay, these examples, maybe I could have gotten a different graph, but that's funny how that worked out. But anyway, let's do this next one. This next one is similar, but we're in tables instead of in graphs. Okay, we want the limit as x approaches 7 of h of g of x. H of g of x. First thing I'm going to do is let x go to 7 on g. So I go to g. X's are going to 7. Here's 7. Okay. What is x approaching? On the left, it's approaching -5. On the right, it's approaching -5. So I know that this is going to be x is approaching -5. However, is it above -5 or below -5? And be careful. If this is -5, where would -5.00007 be? Where would -5.001 be? It would be on the left of -5, correct? It would be on the left of -5. Now we go to the function h. Let x go to -5, but only on the left. Here's -5. Only on the left. What are we getting closer to? 3. Okay. Probably the toughest part of this whole unit, you guys. So just spend a little time, do a few problems. You'll be fine. Let me make sure. Yep, that was it. Okay.